kind of goofy.
Yeah, I got you out there in Texas, 532. Sounding good, man. Go ahead.
Yeah. Break.
Roger, D. Well, have a good weekend, man. It's on. It's coming in. The weekend's here. Hey, 532, 3 C's a holler. 532, Thunderstick. Do you want a motor?
Yeah, 10-4. Well, the DDRR antenna, though it may be...
Well, you in California? That trembling earth is every day out this way. What's up with you? That happens once in a while back there.
I don't have anything that's strictly on the flat side anymore. I used to have a 6-element beam that was on the flat side, a hot feed 6-element 40-foot-long beam, and I took it down and put up the big 84-foot-long thing, and I run it vertical and flat simultaneously, and then the DDRR...
Hey, Whitey, Bluegill, waving a hand back that way.
I actually built and designed the entire antenna system, and the antenna system is actually set where each driven element is exactly 100 ohms plus or minus J0. So, 2-to-1 SWR is pretty bad, but they're 100 ohms plus or minus J0, and then I put them together with equal length coaxes, and I got a 50 ohm plus or minus J0 read at the input of the T where I combined them. So then the phase shift is created by shifting the elements. The vertical ones and the horizontal elements are all shifted by 90 degrees. So it's like two beams on one boom, one in front of the other by 90 degrees, and then they're fed equally in phase with equal length coax, and they're set for 100 ohms plus or minus J0, their break. I kind of know what I'm doing. By trade, I am a broadcast engineer. I kind of sort of have a grip on all that stuff. So, I did do all that. There is no reactance whatsoever. It's 50 ohms flat plus or minus J0, their break. There is no gamma matches. They're folded dipoles. The driven elements are folded dipoles, and there's no gamma matching whatsoever. You tune the dipole with the length of the dipole at the ends, at the trombone sections at the end of the dipole. And the entire antenna with the trombone individually shows up as 100 ohms plus or minus J0 with mutual reactance taken into consideration. And when they're both fed equally in phase at the T, using the T through the phase section or through the line section to make sure I measured it all the way from the input of the T to the feed point, they come out exactly at 50 ohms plus or minus J0. There's no adjustability, there's no gamma matches, I should say, and it's dead nuts perfect to break.
Oye, esos pinches estaban por eso eran las pinches reglas, loco, ahí de tanto rodillo, eran las pinches reglas vacíos.
That way, if you have 50 ohm feed points, and if you had you can do that, but then you got to play games with the coax and RJ11, there's weird coaxes for 75 ohm, but I didn't want to go down that route. I was going to do it with a capacitor and inductor, and I thought, no, I'm not going to do that either, so I'm going to go ahead and just use custom make the antennas for 100 ohms. You can build an antenna for, 23 ohms, 100 ohms, 500 ohms, whatever you want. You can custom make it, and there's nothing magic about 50 ohms except for that's what the transmitter wants to see. So anyway, I went ahead and just did it that way, and it worked real good. Then I run 7/8 radiacs from the T. Section 7/8 will handle easily the 30 kilowatts that they're going to handle. So right now, it's a real simple, easy design, and it's working real good there, Rick.